Good evening, listeners. Welcome to another edition of our national science magazine, Radioscope. The month of November has been witness to the birth of so many world-famous scientists. Starting from Marie Curie, who was born on the 7th of this month in 1867, to our very own Jagadish Chandra Bose, whose birthday falls on the 30th of November. This penultimate month of the year has given our civilization a good number of leaders in science. Incidentally, 30th November, the birthday of Jagadish Chandra, also happens to be the foundation day of the Bose Institute of Kolkata. Speaking of scientific institutes that focus on tackling disease-causing microbes, as also the Bose Institute does, a particular week in November is very relevant to their efforts. It is called the World Anti-Microbial Awareness Week. We shall be dwelling on it in our program. We have also directed a portion of our energy towards discussing pandemics and its relation to the emerging big data scenario. Last but not the least, we shall bring to you a glimpse of the Nobel Prize Museum in Stockholm, the capital of Sweden. We kick off with some news from Shamaita Das.
Indian Space Research Organisation, or ISRO's heavyweight champion GSLV Mark III, redesigned as Launch Vehicle Mark III, sent tremors across the global space corridors with its recent launch on 23 October 2022. The rocket, popularly known as Bahubali, blasted off from the second launch pad of Sriharikota Space Centre in Bengaluru, carrying a constellation of 36 broadband satellites designed by a UK-based company, OneWeb. The orbit of these satellites is just 1,200 kilometers above Earth's equator that will ensure uninterrupted internet access in remote areas and difficult terrains. S. Somanath, chairperson ISRO, shared that this was the first foray of LVM-3 into the commercial space market, and with it, India joined the elite club of commercial space superpowers. For the first time, a payload of 6 tons was carried to space for future manned missions. The Nobel Prizes for the year 2022 were announced on 3rd October. Swedish geneticist Svante Pääbo won the award in medicine for advancing the understanding of human evolution, while Alan Aspect, John F. Clauser, and Anton Zeilinger received the prize in physics for their breakthrough research in quantum mechanics. Carolyn R. Bartozzi, Morton Meldal, and K. Barry Sharpless together were honored with the Nobel Prize for the development of click chemistry and bioorthogonal chemistry. This year we mark the 100th birth anniversary of G. N. Ramachandran, a physicist par excellence. He is one of the forefathers of structural molecular biology. The triple helix structure of proteins was proposed by Ramachandran in the year 1954, when Watson and Crick's famed double helix was still a year away. Ramachandran plot, a foundational concept used in biochemistry to describe the basic elements of protein structure, was a pioneering work in the field of biochemistry that had further led to many and important discoveries in molecular biology. Nobel Prize dialogue titled Water Matters was held on 23rd October in Japan that explored the myriad ways water interacts with life and how to protect this indispensable resource. Multidimensional voices gathered to discuss how to maximize creativity to approach the mission of being wise custodians of our planet. The Nobel Prize Dialogue is an open cross-disciplinary meeting bringing together a unique constellation of Nobel laureates, world-leading scientists, policymakers, and thought leaders to discuss global issues that affect us all. The conference was live-streamed on various social media platforms for global audience. And now some updates for wildlife enthusiasts. Among 12 countries, India also is a proud host to snow leopards, an exquisite and elusive breed of big cats. However, their population is critically threatened in our country. In an encouraging news, Chief Wildlife Warden Uttarakhand has shared that number of snow leopards have climbed up to 121, which was just a mere 86 6 years ago.
That was Shamaita Das bringing you news from the world of science. Next in Radioscope, we have an interview with Professor Gautam Basu on big data and pandemics. Speaking to him is Dr. Manosh Pratim Das.
We have with us Professor Gautam Basu, former professor of Biophysics at Bose Institute, and he has recently taken a keen interest in big data and pandemics. Of course, we read about this in newspapers, in journals, but don't have a grip on what the relation is like. So we would like to put this question before him. What does big data mean vis-a-vis the COVID or any pandemic?
To make it simple, big data is data. Big data is big. Big means you have enormous amount of data. But just being enormous or big does not make a data big. It also has to be complex. So if you have enormous amount of data that is complex, it is not so easy to analyze the data with standard analytical methods. Like you can take statistical analysis of it, but it will have no meaning. You need special techniques. And often special techniques mean using artificial intelligence based machine learning techniques. There are other non-machine learning techniques too. So what is an example of big data? Today, as we talk, all items that were browsed and bought is big data. All items that were browsed from India but not bought is big data. This is enormous amount of data. If it can be analyzed properly, they can understand the trend of buyers, and therefore they can selectively change their display. They can supply different kinds of advertisements to their browsers, ultimately the aim being profit. So big data, as we understand today, before the pandemic, really was something that was collected, curated, optimized, analyzed by large corporations. The only reason behind it is profit. Data is also sold. People sell data to take money. Let us talk very briefly about the last pandemic that India saw, 1918 to 1920. 2 years, Spanish flu came to India and it killed at least, if not more, 5% of India's population. It came from Mumbai, from the west. It moved east all the way to Kolkata and beyond. The difference between COVID pandemic and the Spanish flu in India was, in Spanish flu, 20 to 40, that was the age group where people died the most. Whereas in COVID, it's not the young generation, but the older people who died the most. Now, data for Spanish flu is available, and as a scientist, there are many people who use that data to analyze, to draw conclusions, but that is post-pandemic data. For COVID, what happened was, it was real-time data that was coming. What kind of data? Infections, death, positivity rate, etc. Healthcare situation. So once we were in the pandemic and this enormous amount of data started coming in, the question came, how can we analyze this data not only to understand the pandemic from an academic viewpoint, but use the analysis to predict future trend. So there was policy involved. Policymakers wanted to know what would happen next month, what would happen next year, so they can change policy. What do I mean by policy? There was lockdown, healthcare, other intervention methods like vaccine. How quickly should I bring a vaccine? Who should I vaccinate first? Because there were limited numbers. So there came analysis of big data.
Right. That brings me to my next question, and that is, how effective has this been? I mean, the forecasting depending on big data, and it would not be irrelevant, I believe, to mention that you yourself have also indulged in this. You have plotted graphs, tried to tell people, inform people how this goes about. So could you please explain how effective this is?
I think the forecasting has been as good as it can be, meaning that all analysis of COVID infections all around the world, they used a model called the SIR model, which was developed in 1920s, and there are variants of it. So remember, the model says how infection will move, but the model has parameters, infectivity rate and how long a person would remain infected. So different areas, depending upon the population, these parameters changed. And therefore, what I want to say is that the models cannot really predict completely, but what they can do, given India's, for example, trend today, say the government has come up with this lockdown and they want to now relax the lockdown. What a modeler can do is can simulate, if you relax the lockdown 10%, what happens, 20%, what happens. Of course, you cannot exactly predict the future, but definitely I would say a little bit into the COVID pandemic, there was enough data to answer grossly, not exactly, policymakers as to what should be done, what should not be done. There is one more big data that I just want to say, that as it is not only how to stop COVID progression, you need to intervene medically. So there was enormous amount of genome sequencing that happened, both the original virus and the variants. And this large amount of genome sequence data is also big data. This big data was shared, and this big data allowed us to identify how the virus was moving from one place to another place. This big data analysis allowed us to predict which ones will be more difficult to contain, which will evade antibodies, and also come up with therapies that would allow us to stop COVID-19. One last thing I want to say in this regard is COVID-19 is still going on. And if you say why, I would say it's going on because of long COVID. And right now, as we speak, analysis and understanding of long COVID is going on with big data analysis from large publicly available databases that are there shared around countries.
Finally, one question that puzzles us a bit, that is, when you collect big data, you are not ignoring the culture. Sometimes the data is culture specific, whether some people want to wear a mask, whether they have a sort of discipline which is absent in some other countries. So culture also becomes a player in this field. Is science becoming a little bit culture specific in this regard? Collecting big data, analyzing it, forecasting on the basis of it, what is your opinion?
Culture, whatever you mean by that, is another dimension to the data. So when data is collected, if it is annotated with what kind of so-called culture is associated with individual case, that will allow the analysis to be even better. I must say that there was a large amount of data collected by companies who did not really share it. And this kind of data was buying trends. What are people buying during COVID? How can I make more profit? So their data is associated with culture, meaning often they know the person who is browsing a website, what is their monthly income or which part of the world they are from. And so I'm sure, I don't know, I don't have access to how they analyze data. I'm sure that also is included in their data analysis. And one of the failures of this COVID big data thing is that large companies who collect the maximum amount of data did not share. So it's a direct conflict with general health and corporate profit.
Thank you, Professor Basu, for shedding light on the relation between big data and pandemics. Thank you for coming to our studios.
Thank you.
You were listening to an interview with Professor Gautam Basu on big data and pandemics. The Nobel Prize Museum in Stockholm offers a unique glimpse of the lives and contributions of the Nobel laureates. Anindya, a teacher of physics in Kolkata, recently got an opportunity to visit the museum. We bring to you an interview where he shares his experiences.
Nobel Prize. It is being given away since 1901 and has a rich history associated with it. Some portions of this history is showcased in a museum in Stockholm, the capital of Sweden. Anindya, teacher of physics of the renowned Hindu school in Kolkata, recently had the opportunity to visit this museum. We have him with us in our studio. Welcome, Anindya, to our studio. Please tell us about your visit and what program did you attend there?
I attended the program named as Nobel Prize Teacher Summit. Every year, this summit occurs in the Nobel Prize Museum. The Nobel Prize Museum is situated in the central part of the Stockholm city, that is Gamla stan. It is a beautiful place. The museum is a very old building, and the entire area of the Gamla stan is a very, very old city.
Amidst this cobbled roads and amidst that apparently old-looking city, there stands a museum.
Yes.
So how big is it? Can we compare it with any modern museum, or it is comparatively smaller in size?
Not so large,
Okay.
but there are approximately 20 to 25 rooms. Every year, the Nobel laureates give some of their memorable items to the Nobel Prize Museum, and all these items are exhibited there. This is a fantastic experience.
Could you give us one example, like what sort of item they had shared with the museum?
Yes, I have seen the bicycle given by Professor Amartya Sen from our India. Simultaneously, I have seen the experimental setup given by Wilhelm Röntgen in 1901.
Röntgen means the discoverer of X-rays.
The X-ray tube is exhibited there.
So that is quite exciting, as we understand. Now, you had the opportunity to speak and listen to one Nobel laureate in science at Stockholm. So who was the scientist and what did he discuss?
I have met 2019 Physics Nobel Prize winner Professor Didier Queloz. According to Professor Queloz, the number of science students are gradually decreasing. It is an alarming situation. We have to fight for this with the teachers, with the scientists and all of us. And we have to encourage science education.
Now, the group that you were in had participants from around 30 countries, you said.
Yes.
Did they concur with what Professor Queloz said? I mean, they were having similar experiences in their country?
All of the teachers are saying that the students in the science streams are gradually decreasing.
So this is an area of concern for all of us, and that was reflected in your discussion. We would like to know your experience of visiting the actual venue where the Nobel Prizes are given away.
It is a rewarding experience. The City Hall, that is the place where the Nobel Prize giving ceremony is done. And this consists of 3 large halls. The first one is Golden Hall. That is a big hall where up to 1970 Nobel Prize giving ceremony was done. But after some time, this hall has been abandoned and a new place is added, that is the Blue Hall. This is bigger than the Golden Hall for better accommodation, and simultaneously there was a meeting hall in which the Nobel Prize announcement was done. We have the opportunity to go to this hall also.
So we are curious to know, as the name suggests, Golden Hall, is it really made of gold?
Yes, really it is made of gold. The walls are completely gold plated. There are 80 million golden cakes all over the wall. It is nearly 200 years old, and it is under the guidance of the Stockholm City Municipality.
Coming to the Blue Hall, again, does the name suggest anything or just a simple nomenclature?
When the Blue Hall was being done, the engineer in the charge, he thought that he will make the hall in such a way that it will be mixed up with the sky. But on the ongoing process of building, he has changed his plan. That's why a new hall has been done, but the Blue Hall name is kept.
So he wanted to represent the wide expanse of the sky through this Blue Hall.
But anyhow, he changed his mind.
Changed his mind. Right. Now, Anindya, you had also the opportunity of visiting one of the schools nearby. So what was your experience like?
The school premises is very much different, and the students get extreme democracy inside the school. Not only that, after the break, we have seen that all the students, all the teachers, with the principals and with all the international guests like us are going to the same canteen and taking lunch in the same bench with the students, with the teachers, with the principal. That is a fantastic experience.
There is a restaurant, as you had shared with us, inside the Nobel Prize Museum. So, how is it special?
As the door to the Nobel Prize Museum opens, you will get the restaurant. It is named as Bistro Nobel. You will not get a lot of food there, but it is very special, and all the chairs that is placed in this restaurant, all the chairs are signed by Nobel laureates with some of their comments. This is a beautiful experience.
So, this is not famous for the variety of food. It is famous for those chairs where the Nobel laureates have signed.
Yes, you may say that.
So, these are the relics of the past, as well as these are our heritage, and this is where you had gone. And thanks for sharing your experiences with us. People who haven't been to this place but have heard about it now knows at least how it looks like, where it is situated, and what purpose it is used for. Thank you, Anindya, for coming to our studios and sharing your experiences with us.
Thank you.
After that interview with Anindya, we come to the last item of today's Radioscope. Dr. Sandipan Ganguly speaks to Durba De on the importance of observing the World Anti-Microbial Awareness Week.
The World Health Organization has declared antimicrobial resistance, or AMR, as one of the top 10 global health threats at the 68th World Health Assembly in May 2015. Since then, World Antimicrobial Awareness Week is a global campaign that is celebrated annually to improve awareness and understanding of antimicrobial resistance and encourage best practices among the public. From 2020 onwards, the Tripartite Executive Committee decided to fix dates to 18th to 24th November every year. The theme of World Antimicrobial Awareness Week 2022 is Preventing Antimicrobial Resistance Together, and the slogan remains Antimicrobials Handle with Care. To understand our growing concern about antimicrobial resistance, we sought answers from Dr. Sandipan Ganguly. Dr. Ganguly is the Deputy Director of Indian Council of Medical Research, NICED, National Institute of Cholera and Enteric Diseases. Dr. Ganguly, why do we need awareness in the society about microbial resistance?
Antimicrobials, including antibiotics, antifungals, antiparasitics, they are medicines used to prevent and treat infections in human, animal, and plants. Antimicrobial resistance occurs mainly with bacteria, but in viral, fungi, parasites, everywhere we can see it. The major concerns are overprescription of antibiotics. Patients, those are given antibiotics, are not finishing them. They are taking partial courses. Overuse of antibiotics in livestock, fish farming and other farming. Poor infection control in different healthcare and hospital settings. Poor hygiene and sanitation. And last but not the least, absence of new antibiotics being discovered and delivered.
Can we say that in this age, when we are narrow focusing on specific individualities, trying to understand genetic markers, would it be wise to approach the resistance problem from genetic viewpoint?
If we can understand exactly how this microbe is getting resistant against those antimicrobial, then this is definitely a very huge success for us, because we can fight against that particular genetic marker. In the similar way, if we know what particular genetic markers are actually affecting that antimicrobial to be antimicrobial resistance in a human, we can also use our therapeutics accordingly. This is really very important and very helpful if we really do understand and know those genetic markers. There are pretty many groups who are actually working, who are actually doing research on finding out these genetic markers, adapting new therapeutics, and also how do we target our drugs. I believe this is one of the few very hot areas on which present research is going on.
Does climate change anyway affect antimicrobial resistance?
Definitely, yes. Very recently in 2018, a group of scientists from United States experimentally showed that increasing local temperature as well as population density are very much associated with increasing antibiotic resistance in common pathogens, especially I would name a few like Escherichia coli, Klebsiella pneumoniae, Staphylococcus aureus. European countries in the southern latitude have a higher incidence of infections due to the ESBL producing Enterobacteriaceae due to intermittent antibiotic usage and selective pressure. Let's say at a temperature of 23 degree, the selection pressure was 10 micromolar. But at a temperature of 29 degree, that selection pressure might be 8 micromolar. So at 23 degree, which actually not causing antimicrobial resistance in me, at 29 degree, that can definitely cause antimicrobial resistance in me.
Can an individual protect himself or herself from antimicrobial resistance?
Antimicrobials are like magic drugs. The one and only way to fight against antimicrobial resistance is rational use of antimicrobials. The only way we can overcome these antimicrobial resistant microbes is a very rational use of antimicrobials, and we have to have a very good policy for that. We already do have a very nice policy, but we have to implement also. We can go to any drug shop and we can ask for any antibiotics XYZ and we can get it very easily. But antibiotic should never be given over the counter. It's not an over the counter drug. When we say abuse is not always meant by that I didn't need antibiotic but I have been given antibiotic or I have chosen antibiotic. It is like my doctor has given me this antibiotic for 7 days, thrice daily, and I have taken thrice daily for 2 days and the fever is gone, so I do not need it anymore. It's the same. Overuse or underuse. Both are equally bad. So we always have to listen to our doctor and we have to take antibiotics or antimicrobials accordingly so that newer AMR, newer superbugs do not come up.
We need new antibiotics.
We have to identify newer antibiotics and we have to use rationally.
It seems as though we cannot make it a full month without a new drug-resistant superbug making headlines in one part of the world or another.
What we are seeing is nothing but the tip of the iceberg. By 2050, all kinds of cancer that will cause the number of death would be much less than the death caused by antimicrobial resistance. So we should be very rational, every one of us, the doctors, the general people, the farmers, everybody.
We profusely thank Dr. Sandipan Ganguly for enlightening us on the rational use of antimicrobials. With that, we come to the end of today's presentation. This episode of Radioscope was brought to you by the Kolkata station of All India Radio. Narration is by Taneya Biswas and the program is produced by Dr. Manoj Pratim Das. Till we meet again, good night and goodbye.